Okay, next other one, completing the square. Find that value for c. That would make a perfect square trinomial where you can make the exact same two parentheses. There's two steps for that. C is equal to b divided by 2 to the second. And then we have to factor after that. The b is 18. Divided by 2 is 9. 9 to the second is 81. So now we have an ABC trinomial. We just factor it. 1 times 81 is 81 positive. Now the signs obviously have to match. We're adding to a positive 18 so that it matches positives. And the beauty of this is it's always the same two factors, 9 and 9. I mean, they multiply to 81, they add to 18. So it's x plus 9 times x plus 9, so it would be x plus 9 to the second, okay? Okay, rewrite the quadratic equation in vertex form. Y equals x to the second plus 14x plus 19. Now this is just taking this and applying. What this means, I haven't done a good job to explain what you're trying to do here, really. I think you get the process, but the point is you're trying to get it from a ABC form to an AHK form, okay? That has three steps. So first thing, remember, these are grouped together. The 19 is kicked out. Then I always put 1x to the second. You always want that as 1. And if it matches up here, you can just drop your plus 14x. And now that's an A, that's a B, and I have to get a new C. Okay? So that's where we apply what we're doing here. So C equals B divided by 2 to the second. So it's 14. That's 7. That's 49. Now, once again, you guys, the only thing you guys cannot forget that you also have to add whatever you brought into this side. It's just a 49. It's not multiplied by anything from the outside. It's just 49. Then we minus 49 from 19. Now, next part, you're just factoring that into two parentheses. Those are easy to factor because we know it's going to be the same factor. 1 times 49 is 49 positive. It would be a positive times a positive because you're adding to try to get positive 14. Okay. All right, make two parentheses, and then it's x plus 7, x plus 7. 19 minus 49 is negative 30. So it's x plus 7 to the second power minus 30. Okay, number 3. Rewrite the quadratic equation in vertex form. Same thing you're trying to do as the last one. Kick it out. You remember I said, did I stutter? No, I didn't. I said 1x squared. So I guess you don't have that up here, so you need to divide this along with this by 6. You can't divide this without dividing that. Not the 17 because we kicked it out. So that's going to be 4x. You should not be leaving that as 24. So A, B, and I got to get myself a new C. Okay, so B is 4. 4 divided by 2 is 2. To the second is 4. Okay, so let's look at my 4. I would add 4, but unfortunately 4 is multiplied by 6. Okay, so you need to multiply your 4 by 6 to know what number you need to add, because you have to balance it out, because you see you had 6x squared, 24x, but you don't have the 6 times 4. 6 times 4 is equivalent to 24. So then you subtract 24 from your negative 17. Okay, so I carry the 6. That doesn't just go away. Now I have to factor that. That's like easy. 1 times 4 is 4. Adding to get positive 4. Look, how's that? Well, pretty easy. It's 2 and 2. Multiplies to 4, adds to 4. X plus 2, x plus 2, minus 41. Okay. So it's x plus 2 squared minus 41. Okay, that's AHK. This was ABC. So this one's easy to find the middle term on it to make a perfect square trinomial with your middle term, two factors of 36 that, you know, add to a certain number. What would that number be if they were the same two factors? Well, the formula you can go to is A times C, the square root of it, and double it. So A is 1, C is 36. So it's square root of 36, then double it. Square root of 36, 6, and then we double it, times it by 2, it's 12. Because if I took that to a table and had to factor it, that'd be 36, two factors of 36, I would add up to 12 is the same two factors. Okay, now I, imaginary or complex numbers. I to the fourth, you write I to the second times I to the second. Well, I to the second is negative 1. So it's 1. It's either going to be positive 1 or negative 1. Okay, because if it's an even power. If it's an odd power, you don't really learn about that until after you take the trig. Adding's easy, blank plus blank I. So the constants combine to 2, and then 16. Subtraction's easy, you make it plus, plus, negative. Now, you reverse those, not in the first one. So negative 5 plus 6 is 1. Negative 2, negative 4 is negative 6i. Okay, this is product. So you got to count the terms. This has 2 and this has 2. So that's the FOIL method, 2 by 2. So 5 times 8, 5 times 2i, negative 3i times 8, and negative 3i times 2i. So you got 40, 10i, negative 24i, and negative 6i to the second. Simplified, 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 not simplified. Okay. 40 plus 6 is 46. 10 plus negative 24 is negative 14i. Okay. Okay. 10 plus 4i divided by 5i. Well, you have to multiply because you can't divide by I. So you need to get the I out with multiplying by an equivalent, a fraction of equivalence, meaning the same top as bottom. It's all driven off the bottom here. That's just one term, so you multiply by I and I. Okay, after I know that, this has two terms, that's one term, and that's one term. Okay, so to find the top and the bottom. Top is two terms by one term, so that's two products to find. 10 times I, and then 4i times I. So 10i, simplified. 4i to the second is not. 4 times negative 1 is negative 4. So you got negative 4 plus 10i. Okay, bottom 5i times I. Some of you might know that in your head. It's 5i squared, but that's 5 times negative 1, which is negative 5. Okay, I'm personally not a fan with negatives on the bottom like that, so positive, positive, negative. If somebody didn't do that, I probably wouldn't mark their answer wrong, but that's just me doing me. 4 divided by 5 is a decimal, so 4/5. Negative 10i divided by 5 is not a decimal, it's negative 2i. Okay, 5 plus 3i divided by 2 minus 4i. You can't divide that mess. You have to get the I from out of the bottom. And since you have two terms here instead of the one term here, you have to employ the conjugate method. Now in the conjugate method, the first term will stay the same, but the second term goes to its opposite. I wasn't very clear about that during the year. First term, conjugate, first term stays same, second one goes into its opposite. Then you have to copy the same thing into your numerator. Whatever you times by has to be an equivalent to one whole, which is, it can be anything, like 3 over 3, 5 over 5, 8 over 8, a million over a million. It has to just match up. So it's 2, 2 by 2. Okay, so top and bottom. So 4 products in each place. Okay, 5 times 2, 5 times 4i, 3i times 2, and 3i times 4i. 10 simplified, 20i simplified, 6i simplified, and 12i to the second. That's 12 times negative 1, which is negative 12. So I'm going to jump down here. 10 and negative 12 add up to negative 2, and then 20 and 6 would make 26i. Okay, then 2 times 2, 2 times 4i, negative 4i times 2, negative 4i times 4i. 4, 8i, negative 8i, and negative 16i to the second, but that becomes negative 16 times negative 1, which is 16. 4 and 16 add up to 20. Okay, and the i's cancel. Okay, they add up to 0. Okay, now with that bit kind of done, well, negative 2 divided by 20 is a decimal. You can either keep it as negative 2/20ths or negative 1/10. And then this divided, that's a decimal. You keep it 26 over 20i. Or you could write it as 13/10 I. Or you could also, heck, you could also make it a mixed number, 1 3/10. I don't care, but it's 3 possible forms. Okay, I got a couple quadratic equations to solve where I is going to arise from the solutions. So, 2 answers, A, C, C. Okay, so you want the A on one side, the C on the other, so negative 3x second minus 8, you get 60, divide by negative 3, you get negative 20. Poke the I out because you had the negative square root, 20 is not on the board, okay? But it divides by 4 from the board, 20 divided by 4 is 5, so 2 and the I has to be inserted. So it's 2i square root of 5, and then the same thing with a negative. Okay, number 9, x to the second minus 6x plus 13 equals 0. Okay, a couple things here. What I want to do is, I want to make that a 14, please. Okay, I would like to make that a 14. Instead of a 13, okay? So, 2 answers, that's A, B, C. So the discriminant. So B, negative 6, and then A is 1, C is 14. So it's 36. 4 times 1 times 14 is 56. And that's negative 20, so you're poking the I out, and when you poke the I out, now you're not allowed to put it in a decimal form. It's not on the board, but it does divide from the board by 4 and 5. So yesterday I left it because it didn't divide by anything. It was prime, but now it's not. So now you put it into the don't put those as your answers. You put it into the quadratic formula. So opposite of B, 6, and then 2 times 1 is 2. Now here's your options for your answers. You can write it in 2 forms. You can just write it like this, 6 plus 2i squared root of 5 over 2, and 6 minus 2i squared root of 5 over 2, or you can divide 6 by 2, 3, plus 1i, because that divided by 2 is 1. The square root stays though, okay? And then just switch it. Either this or this, you pick one. Either this or this.